Hello, welcome to this short video on hypothesis testing. In this video, I'm going to solve one problem on hypothesis testing using z-test for mean. The z-test is a statistical test for mean of a population. It can be used either when the sample size is greater than 30 or the population is normally distributed and sigma is known. So in order to use the z-test for mean, we look for two conditions. The first one is the sample size is greater than 30 or the population is normally distributed. And the second condition is the population standard deviation is known. And if we are using this test, the z-test for mean, we can find the test statistic, and that is given by this formula here. Z is equal to x bar, that is the sample mean, minus the population mean divided by sigma over square root of n. This is the formula to calculate the test statistic. Okay, let's see how we can use z-test to solve a hypothesis testing problem. Here we have the example. A professor wishes to test the claim that the average cost of tuition and fees at a four-year public college is greater than $5,500. He selects a random sample of 49 four-year public colleges and finds the mean to be $5,850. The population standard deviation 650. Is there evidence to support the claim at 5% significance level or at alpha equal to 0.05? So when we read the problem, we can see a lot of things here. The professor wishes to test the claim that the average cost of tuition fee at a four-year public college is greater than, $5,500. We are looking at the average cost. He selects a sample of 49, so sample size you can clearly see, n is more than 30, and he finds the sample mean to be 5850. Population standard deviation is given, and they have given the value of alpha. So what we are going to do first is we are going to set the null and the alternate hypothesis. Here we are saying that the mean is greater than 5,500. So that statement where you see mean is greater than 5,500, that is your alternate hypothesis and that is your claim. Always you know that the null hypothesis contains equal to sign. So null hypothesis will be mean equal to 5,500. And the alternate hypothesis, you can write H sub 1 or HA, H sub A, that is mean is greater than 5,500. And the second one is the claim. Okay, because he wishes to test this claim. Now, if you remember the P method, the steps for P methods in solving the hypothesis test problem, the first thing is to set the null and the alternate hypothesis. That's our first step. Now in second step, we use the information given in the problem to find the test statistic, which is Z equal to sample mean minus population mean divided by population standard deviation divided by the square root of the sample size, which is equal to 5,850 minus 5,500 divided by 650 over the square root of 49. Let's find out what is that equal to. Okay, let's use our calculator to find this. I am going to use that fraction bar there, and in the numerator we have 5,850 minus 5,500 in the denominator 650 over the square root of 49. That is equal to 49 over 13. Let me change that to decimal. So it will be 3.7692. Okay, 3.7692. 3.7692. Now, that is our second step. We get the test value. And after we get the test value, we are going to find the p-value. For the p-value, we know that the standard deviation for the population is given, and the sample size is 49. That means the sampling distribution will be normally distributed. So if I draw the normal curve like this, okay, this is not looking beautiful, but that's my normal curve. Now here, if you look at the hypothesis, you can see that our alternate hypothesis contains greater than sign. Meaning of that is this is the right tail test. So your p-value is in the right tail. So this is the p-value. This area is your p-value. In order to find this p-value, we use the test statistic that we have calculated in the previous step, which is 3.7692. Okay. Now what you have to do is we have to use our calculator and get this area over here in the right tail. So for that, we use second, then vars, then we are looking for number 2. Your lower value over here is 3.7692. 3.7692. The upper value from here, it goes up to infinity, which is E99. Alpha and comma, that's E99. Mean 0, standard deviation 1, that's what we can take here. And then paste. Because we have already standardized to z-score, so we can use mean equal to 0 and standard deviation equal to 1. Okay, the value is 8.1912 e to the negative 5. Meaning of that is e to the negative 5. Meaning of that is you have 0.4 zeros, 0.1234 zeros, and then 81912. So I'm just going to write 8. So that is your p-value. So we are done with our third step. First step, we wrote the null and the alternate hypothesis here. Null and the alternate hypothesis. We have the claim. And also in the alternate hypothesis, we have greater than sign. Meaning of that is this is the right tail test. Here we calculated the z value or the test statistic. And using that test statistic, we found the area on the right tail, which is our p-value. Now what we have to do is we have to compare this p-value with alpha. So this area is our p-value. So we are going to compare the p-value, the calculated p-value, with given significance level alpha. So what we have is our p-value is less than alpha, because your alpha is 0.05, but p is very small. Okay, so p is less than alpha. So meaning of that is if p is less than alpha, we reject the null hypothesis. We reject this. Okay, we are not taking this. Instead, we are taking this. So we reject the null hypothesis. Okay, we reject the null hypothesis. Meaning of that is we are supporting the alternate hypothesis, or we are supporting the claim. So what we can write is there is enough evidence to support the claim at 5% significance level. Okay, that is the end of this short video. I hope you find this helpful. Thank you for watching.